So the first thing you have to do when you use an oscilloscope is to turn the oscilloscope on by depressing the on-off button. And then you have to have some signal that you want to make a measurement with. And you'll notice that the two inputs to the vertical amplifiers, where you normally input the signal, in this case you could input a maximum of 2 different signals, are known as BNCs. A BNC is a connector that consists of a coaxial cable, the connector of which has a ground on the outside and a small pin on the inside which carries a signal. And that's the only type of connector that will connect to this oscilloscope. You can't connect 2 wires from a battery or something like that. If, for example, you want to make a connection with a battery or some other signal source that doesn't have a BNC cable, then you have to use an adapter like the one I'm holding in my hand that has a BNC connector on one end, and then on the other end a ground connector and the signal connector. Remember that this connector that is banana plugs on one end, BNC on the other end, a little lump on the side here indicates that this side is the ground. That should always be where the ground is connected. The red should be where your signal is connected. That can be now coupled, and we can put the input signal in that way. But in this case, we have a signal source that is connected to a BNC connector, and it's simply a matter of snapping on that connector, twisting it into place, and you're ready to make a measurement. All right, so let's talk about what we do when we display the signal for the first time. When we turn it on, somebody else may have used the oscilloscope for a different purpose, and the intensity may be too low and the focus may be misadjusted. So you need first to increase the intensity to a level that's easy to see, and then you need to focus the electron beam so that you have a nice sharp image which you're pleased with on the display. Then you have decided that you're going to apply the signal to amplifier, in this case amplifier number 1. And amplifier number 1, in addition to a gain control, has a number of other controls here. One is the position, allowing you to position the signal anywhere on the front of that screen, and you would normally position that right in the center. Furthermore, there is a switch right below the position control that allows you to display either channel 1 alone or channel 2, which of course is just a straight line because we have no signal connected there, or both at the same time. In this case, let's just display 1 and pretend this is a single input oscilloscope. Then, below that is the gain control on the vertical amplifier. There's a red knob in the center, a gray knob on the outside. Be sure that the calibration, the red knob is a calibration signal. Be sure that is snapped into the detent position on the right hand by turning it fully clockwise. Then you'll notice that there is a ring on the outside that indicates if we have a 1x or straight connection signal into the oscilloscope, what the amplification factor is. In this case, we're on an amplification factor of 0.2 of a volt per division. So what that means is that every division on the oscilloscope here corresponds to 0.2 of a volt in the vertical direction. And hence this signal is approximately 0.4 to 0.5 volts peak-to-peak signal. If that's not large enough, or if that's too large, then we can simply, by turning this knob here, increase or decrease the gain, and hence the size of the signal that we're displaying on the CRT. Of course, we're not changing the signal. All we're doing is changing the display of the signal, and the calibration factor changes. At the bottom here is the coupling. If I have the switch on the right-hand side to AC, then what I've done is I've eliminated a resistive coupling to my signal, and hence I can only display AC signals on the CRT, and all DC signals will be filtered out. So normally you'll have that set on the DC condition. Sometimes if you want to determine where your ground level is, you have a ground switch in the center here, which will bring the line back in the center. Or the third knob, or third major portion of the display on the oscilloscope, is the time base. And the time base, again, has a calibration in the center and a ring around the outside, which determines the rate at which the beam is sweeping across the CRT. Here you can't see it, but if I slow down the CRT to a low rate, then you can see the rate at which the electron beam is sweeping across the CRT. And so simply by changing that, I can change the calibration on time. And in this case, I am at 2 milliseconds per division, which means that 1 centimeter of distance here on the screen of the oscilloscope corresponds to 2 milliseconds in times. Let's turn to the trigger now. The trigger is the means by which we allow the signal to repeat itself and display itself, and in a sense freeze itself on the CRT. As you can see here, when you look at this CRT, it looks like there's no change. It looks like the signal, the sine wave here, is not changing with time. But in fact it is. It's an AC signal, and it's clearly fluctuating with time. You know, if I turn the time base down slow enough, then we can see that in fact there is a time component in there. By properly triggering, however, what I do in triggering is that when I set my trigger properly, I fire the electron beam for the sweep always at the same level, initial level on the signal. So in a sense, the beam paints over itself at a very high rate, exactly over the same location each time, so that it looks like, but it's not really, it looks like only, that that signal is frozen in time. There's a non-triggered signal, and you'll notice that it's kind of weaving back and forth over the screen. If you had to measure that frequency or measure that if that were a time-varying amplitude, it would be difficult to do because it's not frozen. And that's what triggering allows you to do. It allows you to stop and display that signal repetitively in time. How do you do that? What's the proper way of setting up your device to trigger a signal? So in order to trigger, we need to look at the right-hand side of the oscilloscope. Over here, the furthest right range on the face of the oscilloscope, and you'll notice there that there are a number of different controls. And don't be intimidated by all of those controls. Some of those are not going to be used very often. Most importantly, you want to make sure at the bottom here that the input, that is, that the oscilloscope is actually triggering on the input that you've connected. You don't want it triggering on something else, or you don't want it triggering on the 60 hertz line. So this should be set to channel 1, because we're connected to channel 1. If you wanted to trigger on channel 2, you would switch that to channel 2. But in this case, we're on channel 1, and we want to set the second toggle switch to internal, which means it will be triggering internally on the signal applied to the input. We could also have another external trigger that would determine the sweep rate, and we would have to change the switch over here to external, but that, you see, because we have no external, that makes the signal disappear. The other thing that is very important is that we have this set on normal trigger. Now, when you're first starting out, you have a toggle switch here that says auto, normal, and TV. Auto is sort of the easy solution to the problem. That's an auto-triggering device, and maybe when you first turn the oscilloscope on, use the auto trigger. But that doesn't allow you the flexibility that I will show you in just a moment. And then finally, you can trigger on the signal when it's, in this case, as you can see, increasing, or you can trigger when it's decreasing, always at the same level, and that's with the slope control here. The final feature of the oscilloscope then, concerning the trigger, is the level. And you'll notice that I've begun the sweep at a level, somewhat above 0. And I can vary that simply by changing that level. Now notice if I set the level too high, I'm beyond the level of the signal, and the signal disappears from the oscilloscope. When I bring the level down to the maximum value, then I have a sweep. If I bring it down further, then I'm down to 0. Down to the lowest value, and I go beyond that and disappears. So I can use this to trigger or initiate this display at any level within that signal, and that's what the level control allows you to do.